A gas is compressed, and during this process, the surroundings do 50.2 joules of work on the gas. At the same time, the gas absorbs 120 joules of heat from the surroundings. What is the change in the internal energy of the gas? So this is a problem involving the first law of thermodynamics, and we know that the formula for that is delta U equal to Q plus W. Delta U is the change in the internal energy Q is the heat and W is the work. Now the problem is asking for what is the change in the internal energy. So we're looking here for delta U. Now there are some reminders that I need to tell you. Remember that when you are using the first law of thermodynamics, there are sign conventions, whether it's positive or negative Q or positive or negative W. So let's start with Q. Again, Q is your heat. Q can be positive or Q can be negative. So Q is positive when heat is absorbed. Okay, and Q is negative if heat is released. How about W or your work? W is positive if the gas is compressed. And W is negative if the gas expands. So positive for compression, negative for expansion. Now in this problem, it says here, the gas absorbs 120 joules of heat from the surroundings. So your system absorbs heat, so that's positive Q. So your Q is positive 120 joules. And then it says here, a gas is compressed, and during this process, the surroundings do 50.2 joules of work. So compression of the gas and 50 joules of work. So compression, that's positive work. So plus your work is positive 50.2 joules. So your delta U is simply 120 plus 50.2 joules, and that's equal to 170.2 joules. So this is the answer.